Welcome back everyone for another SVSU Math and Physics Resource Center tutoring video. My name is Brendan. I'm going to be your math tutor, and for this video we're going to get into the root test and how we can use it to show convergence or divergence for a series. Alright, hope you guys enjoy the video. Alright, so let's get into the root test. So we're going to start out with a series going from n is equal to k to infinity, where k is just a constant, of a of n, which is a function of n. Okay, and what we're going to do is we're going to take the limit as n approaches infinity of the nth root of the absolute value of a of n. And if we can get that to equal some constant L, we can use these three criteria to help us to determine if the series converges or diverges. So if L is greater than 1, the series is going to diverge. If L is less than 1, the series is going to converge absolutely. And if L is equal to 1, it's the root test is going to be inconclusive, and then that just means we have to try using another series test to be able to determine the convergence of the series. Okay, so if you're looking at these three criteria, these probably look pretty familiar from the ratio test. And the root test is really similar to the ratio test. Really, the only difference is what's going on inside of this limit. So the ratio test was the limit as n approaches infinity of a of n plus 1 over a of n. So here, the root test is just the nth root of a of n. So we don't need that a of n plus 1 term like we do in the ratio test. Okay, so let's kind of see what this looks like with this series that we have written down here. And so when I'm looking at this, the way I know I want to try out using the root test first is when I see powers of n. So that's gonna tell me that I should probably try using the root test, because I might be able to get some things to cancel out. So let's go ahead and try it. So the first thing I'm going to do is I'm going to point out my a of n term. And then we're going to go ahead and plug everything in. So this is going to be the limit as n approaches infinity of the nth root of a absolute value of a of n, which is going to be n to the n, over 2 to the 1 plus 2n absolute value. Okay, so next step, I'm going to write my root as an exponent, a fractional exponent. So this is going to be the limit as n approaches infinity of the absolute value of n to the n over 2 to the 1 plus 2n to the 1 over n. Okay, and then so we can go ahead and take this 1 over n fractional exponent and distribute to both the numerator and the denominator. So this is going to be the limit as n approaches infinity of the absolute value of n to the n raised to the power of 1 over n divided by 2 to the 1 plus 2n to the power of 1 over n. Okay, and so we can, when we have a power raised to another power, we multiply those powers. Okay, so that's going to be this next step. So the limit as n approaches infinity of, so n to the 1 over n, we're going to multiply those two, so it's going to be n times 1 over n. That's just going to end up being n divided by, so when I distribute this power to the other powers, we're going to end up with 2 to the, looks like it's going to be 1 times 1 over n, so it's going to be 1 over n plus 2 times 1 over n, 2n times 1 over n is just going to be plus 2. Okay, and so then our last kind of simplifying step before we evaluate the limit is going to be to simplify this denominator, right? So we can break up those exponents. So this is going to be the limit as n approaches infinity of, let's see, our numerator is going to stay the same, which is just n, divided by, looks like I'm going to have 2 to the 1 over n multiplied by 2 squared, and then absolute value. Okay, so let's go ahead and evaluate the limit. So when I plug in the limit, it looks like I'm going to end up with infinity over, so 2 to the 1 divided by infinity, so 1 over infinity, that's going to go to 0, so this is 2 to the 0 times 2 squared, that's just going to be 4. So anything to the 0 power is 1, so this is going to be infinity over 4, which is just equal to infinity. Okay, so now let's take a look at our criteria. So let's just go down the list. If L is greater than 1, the series diverges. Well, infinity is definitely greater than 1. So then that tells us that this series diverges. Okay, and so if we have our series to diverge based on infinity being greater than 1, then that tells us our series is gonna diverge. Okay, so in the next video, we're gonna go ahead and hope to show some series that are converging using the root test, and then hopefully another one that's gonna show inconclusiveness, and we can test it out with another series test. All right, thank you guys for watching.